All right. DreamSpace. Dreaming your room space with text driven panoramic texture propagation um, by TikTok and some other people. Um, the first image we have real world scene reconstruction, which is nice. That's pretty cool. So it takes this is what it takes in as an input, then it could generate all this stuff: the TV, the cameras, the roof, Zelda. It can make galaxies. It can portray anime on TVs. It can make everything a sci-fi futuristic. It can also create immersive VR experiences.
Oh yeah.
DreamSpace allows users to personalize their own spaces' appearances with text prompts and delivers immersive VR experiences on HMD devices. Given a real world capture room, we generate enchanting and holistic mesh textures based on the user's textual inputs. While ensuring semantic consistency and spatial coherence, the sofa still retains its unrecognizable form as a sofa, but in fantasy styles. Abstract. The fusion-based methods have achieved prominent success in generating 2D forms of media, like images, videos. However, accomplishing proficiencies for scene-level texturing and 3D spatial applications, XR/VR remains constrained, primarily due to the intricate nature of 3D geometry and the necessity for free viewpoint rendering. This paper proposes a novel indoor scene texturing framework which delivers text-driven texture generation with enchanting details and authentic spatial coherence. The key insight is to first imagine a stylized 360-degree panoramic texture from the central viewpoint of the scene and then propagate it to the rest areas with inpainting and imitating techniques. To ensure meaningful and aligned textures to the scene, we develop a novel course defined panoramic texture generation approach with a dual texture alignment, which both considers the geometry and textual cues of the captured scenes. To survive from a cluttered geometry during textual propagation, we design a separated strategy which conducts texture inpainting in confidential regions and then learns an implicit imitating network to synthesize textures included in tiny structured areas. Extensive experiments in the immersive VR experience on real world scenes demonstrate the high quality of the generated textures and the engaging experience on VR headsets. So, um, it seems they hopefully release code.
Oh, they do. But it looks like, or maybe it's just like a GitHub page. But there's a link
Useless.
at the top. Oh yeah, it's
Useless.
just a GitHub page.
Dude,
Lame.
why would you release a paper without releasing code? Just the whole paper could just be faked. I don't know why
Yeah.
people keep doing this, and this is just so stupid. But we'll keep going. Because think about it, what are you hiding? If you already have the paper published, what are you trying to hide?
Yeah.
At that point, like these people, it's probably worse for these people who have something open source, well, just this, but there's no code. So that, there's obviously a reason, and that's probably the code is a mess.
But
And
look at the account.
it might even be such of a mess that it doesn't work at all. Um, this is engineer. Wow, 13 contributions. Dude, this is weak. These are some rookie numbers.
It's crazy. I'll see people with rookie numbers putting out like big project. I wonder what that is.
That's mostly just with the academics.
Yeah.
Real engineers
They're
will
not.
just push all day. Researchers and engineers are completely different. This guy is a researcher. He's not an engineer. Engineers are like real time, every day, solving problems. Academics are like one experiment, move on, next experiment.
Mm-hmm.
All right, but introduction. In our childhood, we might have imagined the world we live in with fantasy looking that follows real world shapes, but beyond reality, such as skies, beds with fancy adventurous decorations, or even virtual windows which gaze upon the galaxy. Nowadays, with the advancement of HMND devices, which is VR, we have the ability to immerse ourselves in virtual scenes with 6D off rendering, which opens up the possibility of experiencing scene assets with very stylized textures. A following question is: can we realize the dream of generating fully immersive scenes with fantasy styles from reality by giving text prompts and automatically transferring details of our living room with enchanting and meaningful details? Over the past few years, enormous efforts have been paid in the field of scene stylization. Uh, Existing methods either only transfer low-level styles, while semantically meaningful textures imitating Van Gogh's paintings instead of generating recognizable visual elements or focus on textual editing. On 3D objects with nerve representation but struggle to generate high fidelity textures for the whole space and achieve real time rendering on HMND devices. With the advancements of diffusion based generative models, Stable Diffusion has become feasible to synthesize images based on text prompts with pleasant looking while maintaining the same scene structure by adding depth edge conditions. Nevertheless, since perspective images fuse only convey a partial experience of the entire 3D scene, it's not trivial to automatically project it to 3D scene geometries. As a result, it usually requires skillful artists to run multiple generations and laboriously perform texture painting with 3D modeling. In this paper, we propose a novel-driven indoor scene texturing framework which allows to generate meaningful and appealing mesh textures of real-world scenes based on text prompts, while preserving semantic consistency and spatial coherence. Um, we should consider the panoramic semantics and consistency in a unified process to ensure a seamlessly texturing result. To this end, they propose to texture scene meshes in a top-down manner, where we first generate an initial panoramic texture at the central viewpoint in a panoramic diffusion process, and then propagate the panoramic texture to the rest of the regions. Meanwhile, both of the initial and the propagated textures will be baked into the resulting model meshes using UV maps, which can be uploaded into a commodity level XR VR HMND device for immersive VR applications. There are some challenges when texturing on unstructured and clustered real-world scenes. To display sharp and visually comfortable content on HMND devices, the desired panoramic texture should be high resolution, free of tealing seams, to avoid the sense of spatial fragmentation and spatially coherent following the equitangular projection. Of all the furniture and room structure, such as the floor and ceiling, should be recognized and not distorted. To fill all of the above demands, we employ a coarse-to-fine panoramic texture generation strategy, where we first generate a low-resolution panorama with a panoramic diffusion model to ensure proper panoramic scene structure, and then upscale it to following equitangular seam fixing to achieve seamless and high-resolution textures. Even with depth or edges as a conditioning input, existing diffusion models cannot ensure adequate alignment between geometry and textures, and such alignment would be inevitably introduce noticeable texture projection artifacts. We propose a novel dual texture alignment strategy where the style first textures and the alignment first textures would be generated and blended according to viewpoint depth changes. In this way, we effectively mitigate the geometry texture misalignment while preserving visually appealing generative styles. Real-world constructed scenes often have intricate occlusions when observing from perspective views. Narrow spaces such as the gaps between the wall-mounted TV and the wall or floor areas under the sofa, or thin structures like plant leaves or legs of the furniture, making it a challenge for viewpoint text painting to effectively cover every aspect of the scene. And to this end, we design a holistic texture propagation pipeline, specifically for regions free of occlusion from the new viewpoint. We employ diffusion-based confidential texture and painting. Then we leverage a coordinate-based implicit texture imitating network, which learns style mappings from real-world colors to stylized designs and imitates textures for the rest of the uncovered regions. By cooperating and painting and imitating techniques, our method smoothly propagates initial panoramic textures to the whole space while preserving spatial coherence. We summarize the technical contributions as follows. First, they propose a novel scene level mesh texturing framework in a top down panoramic manner, which allows users to uh, generate engaging UV textures of real world scenes, of real world reconstructions based on text prompts. Second, we develop a course defined texture generation strategy to ensure the correct perspective and high resolution in a dual texture alignment mechanism to alleviate geometrical misalignment without compromising style quality. To cope with the cluttered real-world geometries, we design a holistic texture propagation paradigm with inpainting and implicit imitation techniques, which smoothly paints the entire space with coherent textures. Finally, extensive experiments on real-world datasets demonstrate that our model achieves significantly better scene-level mesh texturing quality than existing methods. Um, I'm going to skip the introduction or related works um, for the sake of simplicity. But it is a really important section, and I do not recommend skipping that out by any means. Um,
Let's look at that figure.
yeah, so framework of DreamSpace. Given a reconstructed real-world scene and users text prompts, we first generate a high-resolution and geometrically aligned panoramic texture at the central viewpoint, which is the center of the space, I can imagine. Then they propagate the textures in the rest of the regions with holistic texture propagation, where the confidential text and painting fills textures at the large confident areas and the implicit texture imitating predicts colors at the tiny areas. The resulting sea meshes with baked stylized UV textures can be uploaded into HMD devices for immersive VR touring. Um, so sci-fi Zelda. So take the scene, the whole scene. They do a central panoramic view. Then this both goes to panel diffusion model. Then a dual texture text alignment, and then the output is a high resolution stylized panoramic view. It's kind of funny. People don't understand that panoramic pictures are artificial intelligence. Most people now have zero idea how much of their lives are already automated by AI. It's insane.
Yeah.
When you take a panoramic picture with your phone on iPhone, you're actually just using artificial intelligence. How do you think that creates
Yeah.
itself? You think this just creates itself? Nah, it does not. Then the second stage, which is holistic texture propagation. So we have a partially textured scene, and we project to a visible area. We project to a visible area. Then that's stylized to UV text. Then that's split into confident area, tiny area. So confidential texture and painting. At the top here, we have in painting viewpoint visibility filtering. So it's kind of like a camera is upward facing downward on the scene georepresentation. That's an inputting viewpoint. So they're looking up into the middle. Then we're adding masked inpainting. So basically, what that means is we're just masking something. Like it's going invisible, but it might or might not still be there. So then implicit texture imitating. So we send in real colors, CR, and C coordinates, and we pass this into an imitating network, and that outputs the stylized colors, which are CS. Then the last stage is DreamSpaces and VR, which a which are fully stylized scenes with baked textures and immersive touring on HMD. Dude, so what this paper is basically saying is that they could generate scenes of games automatically now.
Yeah.
So they could fully generate an entire scene, like end to end. Um, that's pretty insane. So now, I mean, hopefully, if all the game developers knew of all the AI tools coming out, they could automate probably the entire process of making a game. Like the entire process, from coding to design to, I mean, everything. Scene representation. I think this.
Yeah.
I definitely think this paper could help out the game developers like immediately. It could generate like entire scenes and just like from a symbol, picture, and a text prompt. Um,
Have you seen Prompt to World?
huh?
There's Prompt to World now. Not open source, huh? So useless, but shoot, maybe it's. Hold on, let me pull it up real quick. Let's see here. It's called Narek.
Hmm.
Yeah.
Dude, they added a black hole in the roof.
What? Oh,
The whole room is just in a space. All right, I'm gonna go over the method and then probably the conclusion, and that'll be it.
yeah, that works.
Um, it is a little bit thick. Oh, they have a cyberpunk theme. Where is it? Oh, too far. Too far. Too far. What is cyberpunk? Oh, hmm, I see now. Dude, what I'm thinking about here, man, They could probably just generate like a bunch of rooms for like Batman Arkham games. I think that would be really cool. Um,
Okay.
kind of like an infinitely playable Batman game. That'd be very cool. I would play that all day. Um, if we look at Arkham Knight fight scenes, it could probably generate these like scenes pretty well. So like an entire room like this, you have some stuff on the ground, like I don't know if I'd be able to do in this qual. Actually, it could be able to do this in this quality. Um, but like check out the details. Like Arkham Knight is still one of the most visually beautiful games ever. Um, I don't know if it could generate like a whole scene like this, um, but or at least the space, not the like actual animations. But I think that would be cool. Um, that's what I think about. Or actually, I mean, if you have just an image, some real world applications of this paper I see are, I mean, maybe like for security, you're trying to like protect like someone high up in the government. You could use this and like try to like I don't know predict like the windows being broke. I don't know. Um, Actually, the most important use case I could see for this paper is being generating scenes for video games. So, to generate the high resolution panoramic view with appropriate structure relationship and consistent semantic meaning, we we designed a course to find panoramic texture generation process conditioned on a reconstructed geometry and textural cue. And a dual alignment strategy is selected to alleviate texture misalignment due to the geometry. Once the initialized style view is generated, we project textures to the visible area through UV maps and propagate it with confidential texture and painting for visible areas and new points, and implicit texture imitating for tiny ears, so as to maintain a fully stylized scene mesh. Um, so generating in panoramic space, um, we urge that scene level consider full 360 degree view of the scene as a whole, generating a panoramic texture space, aka through Eicher rectangular projection. What does this word mean? Which includes a spatial case is a simple map projection attributed to who. So is this is panoramic? Yeah. So this is panoramic. That's what Eicher rectangular. I don't know how to say it. Um, So the projection maps meridians to vertical straight lines of consistent spacing for meridional intervals of consistent spacing, and circles of latitude to horizontal straight lines of constant space. The projection is neither equal nor conformal because of the distortions introduced by this projection. Um, so, um, equidistical psychological projection includes the special case of Laplace Curie projection, which is a map projection. Um, Um, I'll be back in a sec. All right, I'm back. Um, I curve rectangular projection rather than using multiple perspective or cube maps with perplexing viewpoint-specific prompts. To this end, given a user prompt and a reconstructed real-world scene, our first attempt is to generate a vivid and highly resolution stylized panoramic view that observes the scene from a central viewpoint, which I can imagine is just the middle of the scene. While it is possible to use a depth-aware latent diffusion model to generate textures that fit to the observed scene depth, we find it is still faced with several challenges. Existing generic or lower fine-tuned LDMs cannot ensure accurate rectangular problems projection, which results in distorted texture when projecting back to the mesh. Second, the desired panoramic texture should be high resolution, 2K resolution or more, and free of tilling seams to guarantee acceptable visual quality in immersive VR applications, which is not directly feasible for text generation methods. Coarse to fine condition generation. To handle the challenges above, we designed a coarse to fine condition paradigm where we first generate a low resolution panoramic view with a proper spatial structure, and then upscale it to high resolution. They first train a panoramic diffusion model by fine tuning a generic latent diffusion model with carefully filtered I-curve rectangular projected images. Next, for an input textured scene mesh, we render the panoramic colored image LP with a distance map and distance map D, distance from a camera center to mesh center at the same center, and feed them together with users prompts P to the fine-tuned LDM with multi-condition controls to obtain stylized images ls as ls equals fc p d e ip. Ls equals fc times p and d and e times ip, where fc is the latent diffusion model with multi-conditioning. EIP is the soft edge map extracted with the suit L's work. During the inference, we adapt the asymmetric tilling strategy by hijacking all the 2D convolutions of the unit with horizontal circular padding for the last 60% time steps, so as to make sure the left and right side of the equirectangular image can be continuous. Then we utilize the tile diffusion with a generic latent diffusion model to upscale the LS into ILSL, which produces 3 times larger panoramic images with extra rich details. Accurate rectangulars seem fit. During the upscaling stage, we find that the tiled upscaling strategy would inevitably break the accurate rectangular traits of the image. Patterns became no longer tilting along the horizontal direction, and the top and lower part of the panoramic are not the correct stretching follows rectangular projection, primarily due to the reason that each process tile is agnostic to the full perspective knowledge. Therefore, we also conduct a painting of the whole top-down polar and left-right tilling side of the image. We unwrap the panorama to the upward and downward perspective and impate the central disk area and then warp it back. For the horizontal tilling scene, we roll the half image along the x-axis and paint the middle part that covers both left-right sides of the panorama. We can obtain a highly resolution stylized panoramic images that satisfies equirectangular projection and also maintains semantic coherence. Dual texture alignment. Dilemma of stylization and alignment. Although using depth or hedges as conditional control can effectively direct the LDM to produce somewhat consistent textures to the target mesh, we find in scene level texturing tasks such alignment is not sufficient since the geometry of the real world scenes is much more complicated than single objects. One workaround is to denoise with moderate or small noises upon real image views, aka latent diffusion models image to image mode with lower denoising strength. However, due to the incomplete denoising process, such a method would generally result in blurry or unsatisfactory styles. They are faced with the dilemma that the visually appearing viewpoint, stylization, and perfect geometric alignment cannot be achieved together all at one time. Alignment with texture blending. To solve this dilemma, they propose to break down the stylized panoramic texture generation in a dual process, and then fuse the panoramic texture generation in a dual process, and then fuse the dual textures in a geometrical aware manner. For brevity, we name these dual texture styles first panorama and align first panorama. See the first part, figure 3, where the first one is synthesized in a way which ensures high quality styles, and the second one is synthesized with a custom aligned diffusion process that tends to align the original scene more strictly while maintaining a similar style. Specifically for generating a live first panorama IA, we start by denoising on the rule of preference panorama but utilize multi-control techniques such as IA is equal to FC multiplied with P, C multiplied with IP, and T, I'm going to call that T for now, multiply with IS. I keep forgetting what the symbol is. Also, I can't copy that. Okay, so dual texture alignment. We have the reference panel. This then goes into panel diffusion, which generates the panorama. Then this is style injected into a line diffusion, which then aligns the first panorama. And then this then goes into the blended panel with the style first panel. And then a depth map edge detection is also utilized to analyze the depths of the image, which literally means, as it sounds, the depth or the edges. And then we get an image that incorporates all of these activities. Um, so mitigate misalignment. Um, mitigate misalignment. So here we have a bunch of images. Preserve stylized details. Reference black and white. Before a line. After a line. This one just doesn't seem real. Physically real. I don't know. There's something wrong about the physics in this image.
Normal.
Huh? What'd you say?
It looks really. Well, I guess you can't really. Well, I don't know. I don't think that's a good demonstration picture. It's hard to tell where the lamp is resting.
Yeah. To mitigate to mitigate geometry texture misalignment, we first synthesize. What does that mean? We first synthesize style first panorama and align first panorama, and then blend these dual textures according to the depth etch detection, which brings aligned panoramic textures, while preserving visually appearing stylized details. Alignment with dual texture blending. To solve this dilemma, they propose to break the stylized panoramic texture generation in a dual process. Well, we already read this. I'm gonna feed this into GPT-4 and see if I'm doing it wrong. I have a feeling I'm doing it wrong. Um, Is that the image? Yeah. Write the equation in standard English. I was wrong. So the adjusted panorama represented by IA is equal to a function fc which takes in parameters p, the Kenny edge control of IP represented by CIP, and the tau control of LS represented by TLS. I thought I was just doing multiplication, but no, it wasn't. So they mitigate geometry texture misalignment while maintaining the desired stylized details. Holistic texture propagation, panoramic texture projection through UV maps. Once the initial stylized panoramic view is synthesized, we project it to the visible area through UV maps in the panoramic space. In practice, we first obtain scene coordinates x, 3D position for valid pixels p, in the corresponding UV map as x interpret map text coord p, and a dictionary of t, where text coord p is the texture coordinate of each p, and T, or is the masked triangles. Maps text maps the textual coordinates into triangle vertices with barycentric weights, and each x is a barycentric interpolated with from the trials vertices. Next, for each x, we compute ray directions from the observing camera center C, and the map the direction D, C minus x, the absolute value of C minus x to the panoramic space to rectangular projection. I'm also going to feed this into GPT-4 and see if I'm right. Like, how do you say this in English? Let's see. The scene coordinate x is determined by interpolating the map texture using the function map text. The function takes in the texture coordinates of the point P denoted by text along with a set of mesh triangles. Yeah, I think I read that right. So next, for each x, we compute ray directions from the observing camera center C, and the map the direction D equals C minus x divided by the absolute value. Oh, I already read this. We go through all the UV pixels with the visibility test and form an initial visibility mask. M init vis on the UV space as M init vis is a function applied to P, which equals 1 if the absolute value of P minus X is less than E, or what is it, epsilon, I think. Is that epsilon? Greek symbol E. It is epsilon. Wait, so eta, zeta, epsilon. I didn't even know zeta was a letter in Greek. That's cool. I didn't know that. Yeah, so 1 if the absolute value of P minus X is less than epsilon, 0 otherwise. We assign stylized panoramic colors to the UV space according to the initial value. Separated strategies for confidential and tiny areas by projecting initial scene textures to the scene. The main impression of the stylized space has already been shaped, while there are still some uncovered areas that need to be fulfilled. The gray region at the partially textured mesh, previous methods that use LDM for texturing mainly rely on inpinning with various area projection and masking methods. So we take reference panorama before imitating unfilled areas in black color. So after imitating, wow. So they're just taking their unfilled areas in black color. So the black basically means that like it could be filled up with something. So unfilled areas in black color. So this is with the mask that they're doing, the masking. So they're vision of imitating. Yeah, basically they're just the black parts. They're just filling those in with stuff. Real UV text CR, as stated earlier, which is a real UV texture CR and the stylized UV texture. Then you map a UV texture to scene coordinates X, and then we get a real world inputs as picture, training stage, supervised style. It could become anything. Real world inputs, this room, imitating stage, it added lamps, a wooden thing, and completely changed the roof. We first look, then during the training stage, we train an implicit texture imitating network from a visible stylized area using lifted real-world styles and coordinates. During the imitation stage, we feed the real-world colors and coordinates into the network to imitate possible textures in unseen areas. So for real-world scene texturing with cluttered geometries, it relies on automatic inpainting and cannot ensure proper texturing for thin structures. Duplicated inpainting on the same area on the mesh surface would also result in a blurry appearance due to the inconsistency nature of latent diffusion models and inpainting results. Therefore, they propose separate strategies for areas with different visibility. Instead of conducting inpainting multiple times, we only inpaint at the confidential areas that is definitely free of occlusion, and very few viewpoints. They leverage a novel implicit texturing network to smoothly fill the rest of the areas with plausible appearance. Um, um, so, where were we? It's just super laggy. I can't do anything. All right, nice. So confidential texture and painting. Given a partially textured mesh, we first perform confidential texture and painting in the panoramic space. We do not aim to fulfill every aspect of the space, but only cover the confidential areas that are totally free of occlusion when observing from new viewpoints, where the viewpoint can be selected by SFM poses, which with furthest point sampling or interactive user selection. Basically, what this means is they can choose where they want to look inside of the scene with some methods like SFM or interactive user selection. To begin with, for each viewpoint, we first determine the panoramic and painting mask from the new camera poses. Practically, we reuse the UV space initial visibility mask by regarding it as the UV texture and render the panoramic image on the current viewpoint, and then perform dilation and blurring to the image to obtain the MNIB, which then leverage depth-aware and painting LDMs, such as IMP equals FMP mapped to P, IMD, M, and IP, or IM is the rendered panoramic image with partially textured mesh. IMP is the inpainting output image. The inpainting result will not be fully projected by the stylized texture, but only regain confidential areas by UV space mask filtering. M depth edge, which can be constructed by assigning the UV mask with panoramic depth edge detection. Second, we consider the surface normal and distances by rejecting small gazing viewing angles. Our two face surface points, distance larger than 2.5 meters to form a viewing mask. They perform visibility tests on the inpainting views with a similar structure, which combine the strokes of the inpainting visibility mask. They combine all the masks to achieve a confidential texture projecting areas in UV space, such as mconfig equals m depth edge, which is what does that symbol mean? I forgot. And is a part of list of logic symbols. Let's go with some logic, man. Change. Dude, are you seeing this? Look how many symbols of logic there are. This does not look logical to me at all. Too logical and operate. So implies if then. So you see, like this, we need the opposite of that one.
Yeah, I wonder if there's a good.
What happened?
I wonder if there's a better way to like look those up quickly.
You just have a massive database of them. There's no other way, man. Everything is just like there needs to be multiple of them. Like there needs to be like a database. This is probably one of the best I've seen. You'd also do calculus symbols, Wikipedia, and see if that works. Yeah, I think it does work. Yeah, so you see like something like this. So the R that always comes up, that's a real number. C is a complex number. We have pi, we have golden ratio, which is theta most of the time. Uh, I is an imaginary unit. Um, oh, the T thing, that's actually tau. TAU in Greek.
And it's all changes based on the content.
What happened?
This all changes based on context, though.
Yeah, but some of them will never change. Like the equal sign. Maybe that one's the only one.
Well, maybe. I guess it depends on how many. Whether you're signing equal to, or you can use equals as assignment as well.
Yeah. Here's the sigma and the multiplication, which I always mess up. We have infinity, a bunch of arrows, which mean uh, basically the limit of a function. Differential calculus, we have the derivative or primes. The more primes, each derivative. We have integral calculus, which are, I mean, 3 integrals. That's pretty insane, man. What the fuck? So if a volume integral refers to an integral over a 3-dimensional domain. Oh, that's not bad. I think it could be actually no. It could be horrible. A volume refers to an integral over a 3-dimensional domain. Calculate flux densities or calculate mass from a corresponding density function. So this is pretty important, this vector calculus symbols. So that's the upside down triangle or pyramid means the gradient. And then if you see multiplied v times f, that means the divergence. Then the gradient times f is the curl, which is this super cool. The curl at the point in the field is represented by a vector whose length and direction denotes the magnitude. That's really cool. Then you have vectors and matrices. This is just a vector, pretty simple. But then once you have shit like this is a matrix. Oh, these are also pretty important. These two are means dot product. So the dot product is just takes. It's just addition, I guess, basically. Then you have the cross product, which is basically multiplication. Then, if you have this, you have the diadict product. Um, so if this thing that you see pop up all the time, the double line, that means a norm. Um, I always forget that one. And then there's a lot. The T is really important. The transposition is used a lot. Basically, it just flips a vector the other way around. So like you saw how like it was like horizontal now. It was horizontal, and then it flipped. So basically, like you're taking the diagonal and then you're flipping it on the diagonal. That is used a lot in machine learning. A lot. Basically, almost every algorithm, every machine learning algorithm will use this in some capacity. Um, yeah, but enough of these symbols. Um,
They've been run experiments.
they created a new data set on meeting room, living room, and bedroom. So living room, whoa. Meeting room, galaxy theme, MV diffusion, texture. We compare scene level measuring text with style mesh, MV diffusion, and text texture. Art captured DreamSpace dataset. Yeah, you can tell very easily that theirs is more in detail. Look at that. Dude, it literally looks like you're in a spaceship or something. Original scene style mesh. Um, Original scene. Hmm. The cyberpunk one is really good. Cyberpunk team.
They just need to release the code.
Yeah, look how detailed this is. A little bit. There's obviously going to still be some problems, but I mean, with some fine tuning, this could be like ready to go in like a AAA video game. And this one too. That outside looks really good. Um, Minimalist Zen, dude, that looks amazing. That water there, that looks really good. Um, uh, hmm. Let's see, scene reconstruction of James Spot bedroom. The universe cube map texture. It's like a cube texture synthesis in different spaces. Um, hmm. To ensure global consistency and spatial coherence for the scene level mesh texturing task, the texture should first be synthesized in a panoramic space with icorectangular projection, rather than using multi-view fashion. Um, Due to the discontinuity and unclear spatial semantic meaning, cube-map textures tend to produce excessive details on top of faces, and to fail to make a smooth content transition on disconnected edges, which results in a spurious textures on the roof and mixed tense textures on the chair. Generating textures in panoramic space like ours not only achieves better results, meaning what it lets a fine-tuned diffusion model know that the upper image is the ceiling and the bottom image or area is the floor, but also ensures global continuity and coherence. Um, the galaxy. So input stylized dream spot bedroom with transparent window. Then the input was panoramic galaxy by unconstrained diffusion. Yeah, dude, I would love to live in this house, just stuck in the middle of the universe. That would be nice. Um, Conclusion. We are proposing novel text-driven indoor scene texturing framework which enables to generate high-resolution, semantic, meaningful UV textures for high real-world scenes based on text prompts. The key insight for our work is to first synthesize a stylized panoramic view of the scene that already conveys a global consistent appearance, and then propagates it to the rest regions. For texture propagation, we design novel confidential painting and implicit imitating techniques which properly handle cluttered rural geometry and maintain spatial coherence for occluded areas or thin structures. The resulting stylized texture models can be feasibly uploaded into HMD devices, which delivers immersive VR experiences. Despite the novel scene texturing capability provided by our method, it still has some limitations. The panoramic texture synthesized by our method already bakes the scene lighting effects with two viewpoint in paintings. Are we in the right page? No. So which cannot support custom lighting or dynamic shadows in the rendering pipeline. To ensure high quality texturing and a completely immersive VR experience, our method requires the input reconstruction to include real world textures and also rely on the quality of the scene reconstruction. A complete scan scenes or method does not support extra large rooms. The um, theater or church or outdoor spaces. As such, scenarios might need multiple partition stylized panoramas to fill the entire scene. They plan to support PBR texturing by fine-tuning the latent diffusion model with PBR-based equirectangular projections, which would be more compatible with modern, feasible, physically based rendering pipelines. Besides, we also incorporate our scene texturing pipeline with a visual positioning system so as to align the stylized scene with the physics real world on HMD devices, which could deliver appealing MR experiences. And that's it. This paper, I would rate it a 7 out of 10. It might be state of the art, but there's no code. And
Yeah.
it's very convoluted. There's a lot of scene. I think I've read the word scene representations 1,000 times. They could have provided an algorithm, pseudocode to better show the algorithm. It's still really convoluted, not really simple and direct. Um, but I think that the results are definitely show themselves, and that's why it's the 7. The results are really good. This is a step in the this is definitely a step in the way of scene representation. Um, with Yeah, this is definitely a step in the way of scene representation. There's a lot that can be improved as always, but I think if they open source the code, they could do better.
Yeah.
Um,
Yeah. Thanks for reading. That was a good one. Definitely.
the biggest use cases I could see for this paper are generating scenes for video games. VR, of course, they're already doing VR, but the thing is, that's not really useful. Like, why are people gonna go into a VR just to walk around in a room? Are they playing like a room simulator? Like, like there's the only this would only could only really be useful in a game. People aren't just gonna use a VR to just walk around a pretty dead space with nothing to interact with.
Well, this would work best with
If
MR, mixed reality, where you could essentially everyone just walks around with little neural links and puts a skin on their reality, essentially.
Yeah, that's also another good use case. Yeah, that's a pretty good use case. It would be really cool if they could get the galaxy. Imagine you were in this room, but the galaxy was dynamic and it was moving around.
Yeah.
That would be super fucking cool. I would want to use this immediately. So like literally imagine you're in this room, but like instead of this just being an image, it's actually moving and things are happening. It's
have to create like shader type figures and apply it to all the different parts. But yeah, definitely doable.
Yeah. So games.
There's this.
Yeah.
There's this plugin that I use for Unreal that, like, in real time you can update textures dynamically, and if this could generate just, how they'll generate videos, but they're kind of just images layer after layer. You could add something like that fairly easily and generate like a pseudo video texture world.
Yeah, that'd be nice. Yeah, so I definitely think games, AR, what else? I think that's it. Games and AR would be the two biggest use cases for this model.
Yeah.